In this lesson, we're going to introduce derivatives of the remaining four trigonometric functions, the tangent, cotangent, secant, and cosecant functions. We'll begin with a short review of some trigonometric identities that will be useful as we come up with these derivatives, and then we'll look at the formulas for the derivatives of those four functions. Let's take a look at some of those trigonometric identities that will be useful. To begin with, it will help to recall what a trigonometric identity is. We used one of these when we came up with the derivative of the sine function. We used a trigonometric identity called the sum formula for sine. Here is how we stated it. The sine of a plus b equals the sine of a times the cosine of b plus the cosine of a times the sine of b. And we call this an identity because it's true no matter what. In particular, it's true no matter what values we assign to a and b. And that's sort of the general idea behind a trigonometric identity. It's an equation involving trigonometric functions that's true no matter what values get assigned to any variables that appear in it. And we are going to use some trigonometric identities to come up with the rules or the formulas for the derivatives of the four trigonometric functions besides the sine and cosine functions. Let's take a look at what those identities are. Here's a list of them. One of them says that the tangent of x equals the sine of x over the cosine of x. And again, that's true no matter what value x has. The cotangent of x is equal to the cosine of x over the sine of x. These two are sometimes called quotient identities. There's an identity that says that the secant of x is 1 over the cosine of x, and a similar one that says that the cosecant of x is 1 over the sine of x. These last two are sometimes called reciprocal identities. Finally, there's this identity, the sine squared of x plus the cosine squared of x equals 1. This is sometimes called a Pythagorean identity because it's in effect a trigonometric version of the Pythagorean theorem. And if you look at the first four of this list, or in this list of 5 identities, you'll see that they allow us to express the four functions we're interested in terms of functions whose derivatives we already know, sine, cosine, and the constant 1 function. So we'll be able to use the quotient rule applied to those four quotients in order to figure out the derivatives of the tangent, cotangent, secant, and cosecant functions. The last identity that's in that list, sine squared of x plus cosine squared of x equals 1, will help with simplifying once we've applied the quotient rule. So let's see what the derivatives of those four functions are. We'll start with the tangent function. Our goal is to find the derivative of the tangent of x, the derivative with respect to x. And to do this, we'll use the fact that the tangent of x is equivalent to the sine of x over the cosine of x. And now we'll apply the quotient rule. Low d high minus high d low over low low. So that's what we obtained. The cosine of x times the derivative of the sine of x minus the sine of x times the derivative of the cosine of x over the cosine squared of x. We know what the derivatives of the sine of x and the cosine of x are. The derivative of the sine of x is the cosine of x. The derivative of the cosine of x is negative sine of x. And with a little bit of algebra, we can rewrite those as cosine squared of x plus sine squared of x. And keep in mind that thing in the numerator is what the last of our 5 identities that we listed tells us is equivalent to 1. So we get 1 over the cosine squared of x. And using one of our reciprocal identities, we can rewrite that as the secant squared of x. There's our conclusion. The derivative of the tangent of x is the secant squared of x. So here we use the quotient rule. We used this identity, the tangent of x equals the sine of x over the cosine of x. And then the other key kind of formulas we used are those for the derivative of the sine function, the derivative of the cosine function, and this Pythagorean identity, the cosine squared of x plus the sine squared of x equals 1. For the derivative of the cotangent function, the work is very similar. The difference is that for the cotangent function, we start by rewriting it as the cosine of x over the sine of x, rather than the sine of x over the cosine of x. But after you do that, everything is nearly the same, so we'll leave the details for you to try on your own. I'll just tell you what you should end up with. You will find that the derivative of the cotangent of x is negative cosecant squared of x. Let's turn to the secant function now, and we'll go through the steps to find this derivative as well. We want the derivative of the secant of x, and the secant of x is equivalent to 1 over the cosine of x. So we're now going to apply the quotient rule to 1 over the cosine of x. Here's what we get when we apply the quotient rule. And the two derivatives that you see in the numerator are both derivatives we know. The derivative of 1 is 0, and the derivative of the cosine of x is negative sine of x. So if we continue on here, we get the sine of x over the cosine squared of x. Now that's fine. We could stop there, although it's customary to rewrite this slightly. We can start by rewriting it as a product, 1 over the cosine of x times the sine of x over the cosine of x. And each of those can be expressed using trigonometric identities as respectively the secant of x and the tangent of x. So that is where we will stop. We'll say that the derivative of the secant of x is the secant of x times the tangent of x. And then there's the cosecant function. And again, we won't go through the steps. We'll leave those for you because it's very similar to what we just did for the secant function. The only difference is that we start by rewriting the cosecant of x as 1 over the sine of x. When you're done, after you've applied the quotient rule to 1 over the sine of x, you will obtain this result. The derivative of the cosecant of x is negative cosecant of x times cotangent of x. And that brings us to the end of our introduction of trigonometric derivative formulas. So let's summarize. We now know the derivatives of all 6 trigonometric functions. The derivative of the sine of x is the cosine of x. The derivative of the cosine of x is negative sine of x. The derivative of the tangent of x is secant squared of x. The derivative of the cotangent of x is negative cosecant squared of x. The derivative of the secant of x is the secant of x times the tangent of x. And the derivative of the cosecant of x is negative cosecant of x times cotangent of x. There's quite a bit there, and it can be a little bit difficult to remember. The best way to deal with that is to memorize. Take the time to memorize these 6 formulas here. You'll be using them again and again, and if you have them memorized, you don't need to worry about going to the trouble of deriving these every single time you need one of them. There is, however, a little trick you can use to remember at least some of these. The key here is to observe a certain relationship between each derivative, each trigonometric function's derivative, and the derivative of what's called its co-function. The co-function of a given trigonometric function is the one you get by putting on the co-prefix. So for example, the sine and the cosine function are co-functions. So let's say you want the derivative of one of the 3 functions whose name begins with co. Start with the derivative of the function that doesn't have co in its name. So for example, if you want the derivative of the cotangent function, start with the tangent function. And then make these changes in order to get the derivative of the co-function. So for example, the cotangent function. Switch each function in the derivative to its co-function and make the whole thing negative. So for example, the derivative of the tangent of x is the secant squared of x. Let's say we want to get the derivative of the cotangent of x. This is the co-function of the tangent function. So we'll start by taking the secant squared of x and switching secant to cosecant, its co-function. Then we'll put a negative sign in front, and we get negative cosecant squared of x, which is the derivative of the cotangent of x. So if you can remember this, then you only need to memorize derivatives of the functions that don't have co in their name, sine, tangent, and secant. And you can use this technique to get the other 3. You can also take the time to memorize all 6 of the trigonometric derivative formulas, and then you don't need to worry about remembering these kinds of tricks, although they can be useful.